Dear colleagues, my name is Subbotin. I am representing National University Zaporizhia Polytechnic, and my report is about paper, the quality indicators of decision tree and forest-based models. This study was partly supported by the international projects of Erasmus Plus program funded by the European Union, BioArt and Eliot, and also the study is related to the DAD WIMAX project. On the slide 2, you can see formal problem statement. We have a data sample, consists of inputs and outputs. Each input is a set of input feature values characterizing a specific instance, and also we need associated output feature value for each instance. Taking this information, we able to provide statement of some problems. First problem is a problem of model building. When we have a set of observations and we need to build a model on the basis of decision tree, this means that we need to identify the model structure F and the values of its parameters W, which provide an acceptable value of a given quality function of the model. It's general problem statement for the decision tree model building. Next problem is a problem of model building based on a forest of decision trees. The forest of decision trees is a set of single decision trees providing modeling for the same data sample. So this problem can be formulated as to identify the model structures and values of parameters, providing acceptable value of general criterion. And all these problems, as for the single model, building on the single decision tree, as for the building a set of decision trees as a forest, we need two specific criterions allowing us to reflect main properties of the decision tree of the forest model. And we have a problem of quality functional creation for models based on decision trees and forests. We can view such models as a set of indicators that quantitatively describe the properties of the models. The main goal of this study was to create a set of such indicators, allowing us to reflect main properties for the decision trees and for the decision forests. On the slide 3, you can see primary model characteristics. At the left side, you can see sample properties is an additional notation for the sum properties of samples. It's a test sample, its volume, number of features, maximum and minimum boundary values of model output and output feature. And at the right side of the slide, you can see the most primary properties of a model structure. Number of levels in a tree, number of nodes in the model, number of nodes in the layer, maximum possible number of nodes, function of node, smallest possible change in the real number, complexity of node, characteristics of autonomy of node, characteristics of plasticity of node, and characteristic of connection between nodes. As a slide 4, you can see primary model parameters at the left side, and notation for functioning of a model, and notation for the model training method parameters. Such notation used to provide us designation for the traditional simply measured properties of models and methods used for the model building. On the slide 5, you can see some additional notation. It's notation for the 3 models in a forest and notation for indicators. If we will speak about notation for indicators, we need to take into account that some indicators can be measured for a single tree, but when we try to provide modeling of properties of a set of decision trees, then we also need designation for the same indicator, but for the whole forest. At the slide 6, you can see model quality indicators provided for the sum of k properties of models based on decision trees and forests. The next slides also will show you some of proposed indicators. The definition of such indicators and properties are given in my paper. It requires a lot of time to say about it, but I will say some words about such indicators during my speech. The first property is diversity, and you can see on the slide 6 proposed absolute indicator of limiting diversity for the decision tree and absolute indicator of the limiting diversity of the forest of decision trees. The diversity indicators of the tree and forest models also can be evaluated in relation to the training sample and in relation to the population universe. The next property for which I propose indicators is equivalence. The equivalence coefficient of training model based on decision trees on the same sample can be used to compare these models. It looks like error-based or distance-based function. On the next slide 7, you can see indicators provided for evaluating properties of model retraining and generalization properties. As for the model retraining, I propose to evaluate it according to the training sample and trainings and test samples, especially for classification problems and for evaluation problems. As for the generalization, you can see a proposed indicator for the single decision tree on the basis of training and test samples, and also generalization indicator of trained model and for the forest of decision trees also. As a slide 8, you can see proposed indicators to evaluate the confidence. Confidence means self-evaluation of model, how it is confident in its decision. So it should be viewed something like pseudo self-estimation of reliability or confidence of the model solution. At this slide, you can see proposed confidence indicator for the model, the average confidence of decision tree on the sample, also the confidence for the forest of decision trees for one instance, and indicator of average confidence of forest for the sample. On the slide 9, you can see definitions of indicators to reflect such properties as here hierarchy and elasticity. Here we can measure the hierarchy of a single decision tree and the hierarchy of the forest of decision trees. The elasticity allows us to measure relative elasticity indicator on the model based on decision tree. Next slide 10 show you indicators allowing us to measure robustness. Here you can see indicator for robustness of decision tree in relation to the input signals at the left side and robustness of decision tree respectively to weights or parameters. Also at the end of this slide you can see integral robustness indicator for the decision tree. On the next slide you can see indicators for the nonlinearity and equifinality. At the left you can see indicator for classification problem, it's nonlinearity indicator, and at the right you can see nonlinearity indicator for the estimation problems. Next you can see indicator of compliance of nonlinearities of the sample and the model. And as for the equifinality, I propose relative equifinality of a model for the single decision trees, a tree, and the relative equifinality indicator for the forest of the decision trees. On the next slide, you can see indicators proposed to measure homogeneity of the nodes of the decision tree and homogeneity of the node functions of a forest. The next property for which I propose indicators is a sensitivity. Here you can see the averaged normalized indicator of the sensitivity of the output of the decision tree to change in the input signal, and the average indicator of the sensitivity of the forest to changes in the input signals. Next slide show you indicators proposed to measure variability and plasticity. Here you can see the absolute indicator of the model variability and the absolute indicator of the variability for the forest. Also for the plasticity, I propose a relative indicator of the plasticity of the nodes, relative plasticity indicator of adjustable model parameters, the relative indicator of plasticity of a model, and also the same indicators for the decision tree forest. The next slide show you indicators proposed to measure noise resistance and model adaptability. Next slide show you indicators to measure symmetry and asymmetry, and also indicators to measure emergence on integrity. On the slide 16, you can see proposed set of indicators to measure interpretability or logical transparency of a model according to single decision tree or also for the forest of decision trees. Also, I propose indicator to measure learnability as for the single tree as for the forest, and indicators to measure the autonomy of single decision tree model and forest of the decision trees. So we have a set of primary properties of a model and also set of proposed indicators reflecting separately each of properties. But it is very useful for the practice to have a specific integrated indicators. So on the current slide, you can see 17 slide, I propose several integral indicators combining the before proposed indicators for separate properties. It's an integral information criterion of a model. Also, it's generalized indicator of the model effectiveness and generalized indicator of model efficiency. As the practice user or customer can provide a list of most important features or properties that he or she need to be provided by the model. And having such list, we can use proposed at the previous slides indicators to combine them and resolve as a result integral indicator reflecting set of different properties of the models important for specific task. And such indicators can show us numerical evaluation of model quality, and also can be used to compare the models or to optimize the model, to identify or optimize model structure, model parameters, etc. On the next slide, you can see a big diagram showing us whole set of primary and proposed indicators, and you can see particularly their relations. Such diagram is important for the computational point of view, because some of indicators reflects basic properties. Some primary indicators need to be computed using the basic properties. Some of secondary indicators need computation of primary indicators, and integrative indicators need computation of more simple secondary or primary indicators or basic properties. So having this diagram at the practice, designer of model or designer of software can organize specific computational schema to provide effective computation without repetitions, and this makes computational process more effective using this table. As a conclusion of my work, I want to say that this study is resulted in creation of a set of indicators reflecting main properties of the models for the decision trees or decision forests, and such a set of indicators characterizing main properties of the decision trees and forests is proposed in my work. It allows quantitatively evaluate such properties as diversity, equivalence, training, confidence, hierarchy, equifinality, generalization, linearity, robustness, homogeneity, sensitivity, plasticity, variability, adaptivity, symmetry, asymmetry, emergency, interpretability, learnability, autonomy, and as for the single trees, and also for the forests of decision trees. As for the prospects for the study, I want to point that we need to obtain estimates of computational and spatial complexities of calculation that proposed indicators. Also, we need to study the proposed set of indicators on a real practical tasks, studying effectiveness of such indicators in practice, generally studying its applicability, and maybe also it is important to find a possible relationship between different indicators to simplify the computational complexity for possible software realization of these indicators. So thank you very much for your time, and I will be happy if somebody will interested in this work, and it will be useful for practical application in cases of model building based on the decision trees or decision forests.